Honda unveiled the first fully articulated humanoid robot in 2000, Asimo. It can now walk, run, climb stairs, and interact with humans. In 2005, the South Korean university KAIST introduced their response, the Hubo biped, capable of similar feats. Like the space race of the 60s, humanoid research is the new frontier. Unfortunately, America's focus on military robotics has left it a low priority. The PIRE project was conceived to bring humanoid research tools to universities nationwide and reverse this trend. In September of 2006, the Drexel Autonomous Systems Lab was introduced to the Hubo at NextFest in New York City. Struck by the Hubo's sophistication, a delegation of American researchers then visited KAIST's Hubo lab in Daejeon, South Korea. Surrounded by treadmills and computers, the students demonstrated their crown jewel. Hubo could walk, turn, climb stairs, and even balance on one foot. Microphones and cameras in the head allowed it to accept voice commands and interact with guests. Its choreographed motions appeared almost human. The visit really emphasized that Korean robots are people-oriented. Other labs on campus researched robots to help the elderly, help with housework, or even entertain children. American robots are cutting-edge, but very specialized. MIT's Kismet mimics human faces, the Boston Dynamics Big Dog to negotiate very rough terrain. The Denise semi-passive walker maximizes gait efficiency. Yet no such project has produced as complete a robot as Hubo. Our fusion of American and Korean research will deliver a universal biped to walk anywhere, operate human interfaces, and even socialize with people. KAIST's Hubo Lab supplies the research backbone, a complete Hubo. Bryn Mawr College will produce the open-source virtual Hubo, a computer model and simulator of the Hubo robot. When completed, the software package will include a solid model, a dynamic simulator, and a virtual test environment. The 17-inch Darwin humanoid from Virginia Tech will become the Mini Hubo. Its servos and sensors replicate the Hubo's behavior in an inexpensive and compact system. Drexel University will modify its Systems Integrated Sensor Test Rig, or SISTER, to accommodate the Hubo. Its gantry arm will follow and record Hubo's movements. In case of a crash, the restraining harness will prevent a fall and recover the Hubo, so the entire experiment can be run remotely. For instance, the University of Pennsylvania's GRASP lab is working with DARPA's Little Dog, developing walking algorithms for rough and rocky terrain. They will apply these tools to adapt such capabilities to the Hubo. Colby College's vision experts will add audio and visual perception. Using the existing camera and microphone, the Hubo will perceive rather than record its environment. Recognizing faces and natural language is a first step to a social robot. Over the next 5 years, 20 undergraduates will travel to South Korea for 6-month co-ops at the KAIST Hubo Lab. Hubo will also be available at public venues, namely the Please Touch Museum of Philadelphia. Our public success will advance humanoid robotics from a curiosity to a reality.
I am Albert Hubo. Very nice to meet you all.